This live stream broadcast is brought to you by the efforts of Diabetes Mine, a gold mine of straight talk and encouragement. Tidepool, stewards of your data, proudly nonprofit. The Nightscout Foundation, open source, open data, open hearts. We would like to thank Amy Tenderich for hosting this event, and Brandon Arbiter for recommending Nate Racklyeft for this event. From the University of California Mission Bay campus on October 27, 2016, Diabetes Mine presents DDATA Exchange, where innovators connect. Today's host is Amy Tenderich, journalist, blogger, patient advocate, and consultant who founded Diabetes Mine after her diagnosis with type 1 diabetes in 2003. Today's broadcast is episode 8 of Are We There Yet in T1 Tech? Nate Racklyft's presentation is on building amazing diabetes apps. Nate has raised the bar with his diabetes app Loop and LoopKit, and has challenged all those that build diabetes apps to raise the bar also. Nate is a graduate of the University of Michigan with a degree in biomedical engineering and was recently hired at Apple. Please welcome Amy Tenderich and Nate Racklyeft to our broadcast.
Now, I would like to get started by introducing our featured speaker this morning, Nate Racklyeft. And while he makes his way up here, so Nate was diagnosed at age 8. His sister and grandfather have also had diabetes. He has a degree in biomedical engineering from the University of Michigan, after which he developed software for stocks, beer, and yoga in India and Chicago, before moving to San Francisco to work on ads at Google. And he also later led the mobile development at Cherish, which is an online marketplace for high-end home decor. But he joined the OpenAPS project in early 2015, and he's been successfully running his own DIY artificial pancreas and tinkering with it ever since. By the way, Nate recently joined Apple, but we want to make sure that it's clear he's here speaking from his own perspective with his, on his own behalf. Welcome, Nate.
Thank you, Carter.
Oh, right. Oh, you have to say it.
Hello.
Can you remind people not to?
Hi. Make sure to keep your bandwidth usage at a minimum so that demos and things can go smoothly. No problem. Thank you all for having me here today. I'm going to be talking about all right, building amazing diabetes apps. And I want to thank Amy and Howard for having me here today. I'm excited for what's going to be a really great DDATA. I'm always look forward to this event. So, a few disclosures before we start, though. I do need to mention that I did recently join Apple. My presentation is going to be about the work I did on the open source projects Loop and LoopKit before that time. And those projects are still in development, and they're being coordinated by Pete Schwam. I'm really excited to have here today. Yes, please clap. Feel free to clap as often as you like as names are said. All right, let's start with a little history about me. So I've had diabetes since 1993. I got my first insulin pump in 2001. 2007, the iPhone came out. And a few years later, I built my first app for it. And then in 2010, I wondered, man, why can't my iPhone talk to my insulin pump? So, as it was fashionable to do at the time, I actually sent an email, as you remember what email looked like in 2010, to the CEO of the company who made my insulin pump. And I started to make demands. That's how things got done in 2010. And I said, Dear Redacted, I've been a customer of yours for 9 years, and I want to offer you my story and my unsolicited advice for the future. When I got my first pump, I was so excited at all the possibilities. As I held it in my hand, I felt the first real advantage over the condition I'd fought since age 8. A lot has changed in the 9 years since that first bolus, though. I graduated high school, college, I work as a software developer. My pump feels like the most low-tech device I use all day now. So, I'm asking you and your board to be bullish on diabetes technology as the pace of innovation in other sectors continues to dwarf the pace in yours. I'll be eagerly awaiting what's next. Regards, Nate Racklyeft, Chicago, Illinois. I felt really good about this email. I thought a change was going to come. I could sit back and wait, and then technology was going to flow into the insulin pump space. So I waited. And I waited. And somewhere in 2015, I asked myself, maybe, why am I still waiting? Thankfully, others were not. Well, I twiddled my thumb. Ben West was decoding the interface to his insulin pump to learn more about it. The potential of that was seen by Dana Lewis and Scott Leibrand, who worked with him to build the OpenAPS toolkit. And if you were at the last two DDATA meetings, you heard Chris Hannemann and Mark Wilson talk about how important their DIY systems are to them and their diabetes control. You might not yet know about the work of Pete Schwam. And Pete has an amazing lab here where he had set out to have an initial goal of get his CGM data from his daughter Riley's CGM into Nightscout, which there wasn't an easy way to do it with her system at the time, and he knew he needed a hardware solution. The pump sends out a little bit of wireless information every few minutes with the CGM data, and so he built a board in this amazing lab to capture that data and translate it to Bluetooth. That board was titled the Racklyeft, and many of you have Racklyefts today. This was really important, and she had CGM data in Nightscout. However, because of the work that Ben had done, he realized that there's more we could do with a Bluetooth interface to a pump. We actually could create a full BLE remote interface to it. And his vision for that was actually a fully compact, automated artificial pancreas that just used these few components. So I co-opted his vision, and with his help, built Loop. So Loop is an app for iOS, watchOS, that connects directly to the CGMs, and with the Racklyeft connects directly to the pump to provide an automated and also semi-automated way to do basal dosing. I've been running it for more than 7 months now. It is my artificial pancreas. But if you're here today, you already know how you feel about DIY devices. And I'm not here to change your mind. Instead, I want to take a step back and, from my experience, give you some challenges and some insights on what makes a good diabetes app. And so, 5 specific things I'm going to challenge you to think about today in your own apps. First, be interoperable. Second, be connected. Third, be transparent. Fourth, be discreet. And fifth, be accessible. All right, tall bill. Let's start with the first one. Be interoperable. What does that mean? Well, let's take Loop for an example. So Loop has a very concise view about what's going on with your diabetes right now. You can never really see more than 24 hours of information in Loop. But it's saving all that data in HealthKit, which is a secure health database that's on the phone. And users can decide to share that health data with other apps. So, while Loop doesn't provide a long-term view, OneDrop actually provides a great long-term view, reading the data from HealthKit. This is what my endocrinologist and I use, actually, during our appointments, is a month-over-month view of my blood sugar, my carbohydrate intake, and my activity. And she can kind of understand where things are trending in just a few minutes. HealthKit provides multiple ways to read and write data, and Loop also reads data from the system as well. It has a very simple carb entry experience on the phone and the watch. You just enter a number. But there are so many other great apps that do carb entry really, really well. And if those apps connect with HealthKit, then Loop will gladly read those carbs in and use it in its algorithm. So LifeSum, for example, has really great restaurant database, ingredient database, meal planning, weight loss plans. These are all things that I was never going to build in my own app. And I didn't have to. I didn't have to focus on a great experience because I knew that these apps who shared their data with HealthKit could be used in Loop. So here's Scott Hanselman's brunch actually showing up right in Loop. Being interoperable allows you to focus on what your app does best. You're not the only health app on the system. All right, let's talk about being connected. Loop has this great experience I mentioned that is available offline, which is really great if you're camping. But Nightscout has showed us that it's really important to have a connected experience with caregivers and friends and family as well. And that was actually a deal breaker for using Loop for a little while, until Pete stepped in and connected Loop to Nightscout by building a custom framework. This was actually really easy, and it provided a really amazing view about what Loop was doing to anybody who had the Nightscout URL. And Nightscout's got a great security model. It gives peace of mind to caregivers, and as a developer, we didn't have to do much work. So I didn't have to worry about my own backend, but I can still provide a great experience. And remember that diabetes requires a team effort, and your app should look to provide a team experience. If you don't have a backend, there's some people here who would love to tell you about how you can integrate with Nightscout. All right. Be transparent. So what does this mean? Well, we're very lucky to have Courtney Elias with here today. And you might have seen a slide that she shared at the American Association of Diabetes Educators Conference earlier this year. Her challenge was that users who have artificial pancreas systems should be reading and checking the code that runs on it. And I think that's really important. I actually would like to see some sort of standard applied to commercial systems like this as well. However, code is getting more complex. Machine learning, artificial intelligence, these things make it really hard to understand by simply reading code what a system is doing. And to illustrate that, I want to show you some code from Loop. It's code that I wrote, but if you showed this to me 2 years ago, I wouldn't understand why it was written or what it's supposed to do. And that's because despite having diabetes for over 20 years at that point, I didn't have a good idea of the mechanics of blood glucose dynamics and effects. And what really changed my perspective and gave me insight was not reading a lot of code, although that did help. It was actually an interactive tool. And this is Glucodyne by Ken and Gustavo, who are here today. And using the work of Gary Shiner, you guys they deserve that clap. They provide an interactive experience of each piece of their algorithm so that users could input their own data and interactively look at all the pieces. They can scrub, they can change things around, pull some levers, and this was really transformative for me. So I wanted to bring that same experience to Loop. So I just copied it, because that's what you should do when something's really good. Loop's version is just like Glucodyne. You can turn on and off components of the algorithm and see how it changes using real live data. And you can scrub and kind of see how everything works together. I believe this is actually much more powerful and accessible to users than just code alone, and allows them to build trust in a system in an era when these systems are getting much more complex. In fact, you might have seen this study that came out last year about the failings of smartphone apps that do insulin dose calculation. The authors set up a set of standards and found that after testing 46 apps, 45 of them actually contained an issue by their definition. I think more disturbing than just that there were minor issues in these apps is that only 30% of them actually documented the formula they were using or explained what they were trying to do with the inputs the user was giving. So this type of black box makes it really hard to find bugs. And actually, it was hard for the researchers to know right away that there was something wrong with some of these apps. But this could have been solved, at least from a user safety issue, by just being more transparent about what the app was intending to do. And I think there's sometimes a balance between simplicity and transparency, but I think there's ways to solve that, and it can really be important to user safety. Bugs do happen. I've written a lot of them in my life. That's just part of developing code. And what's important is not that you say you're never going to write bugs, but that users know when a bug is happening, especially in a medical app, right? So one thing that Loop has is actually a very verbose diagnostic issue report that users can look at and then even share with in any way they like. They're encouraged to send it to GitHub if it is an issue. But some users just like to understand what the system's doing. This shows all the configuration, all the variables in memory, things that didn't go into the user interface, they can pour through them. And it's not just good for users, it's also great for your developers. But this type of complexity, this type of transparency also can bring a lot of trust into users that may not be ready to trust sort of a shiny black box user interface. In fact, I mean, this was the impetus for Ben West doing all the amazing work that he did with his pump, was to really understand what's going on under the hood and can I trust it. So, think about how to earn your users' trust by allowing them to explore your system's complexity. All right. Challenge number 4, be discreet. This word is used a lot, I think, in modern medical devices. But I believe that nobody understands this need for discretion more than a teenager with diabetes. I know that because I was a teenager with diabetes. And the last thing I wanted to do was pull out my diabetes equipment and create an awkward conversation. I just wanted to be cool. I mean, I was, obviously, but I didn't want to jeopardize that at any point. And so one thing I really wish I had as a teenager was the ability to send a bolus from my insulin pump. I could leave all my devices tucked away and no one would be the wiser. In fact, I've heard from a parent of a teenager with diabetes that uses Loop that this really meets their standard for discretion. And you can imagine why, right? Everybody's using their phones anyway. Nobody has to know that there was a bolus or a meal calculation going on one phone. So discretion goes a little further than just hiding things away. It also means valuing the user's time. So notifications that Loop sends have all the information the user needs. They don't have to open the app. This is important because it actually takes seconds or sometimes longer to pull the phone out, to check what's going on, and to maybe dismiss something that really can't be handled, like a reservoir low. It's just something to remember. Furthermore, there's an interactive experience that Loop provides on the Apple Watch for doing meal boluses and carb calculations. And this was actually really important for me at a restaurant a couple months ago that had a no phones at the table policy. I didn't have to create any issues or embarrassment by pulling out devices from my pocket. Nobody was the wiser that I just handled my diabetes discreetly. The other thing too is there are certain pieces of artificial pancreas systems and other just health tasks like uploading to the internet that take a little while, and sometimes they don't always succeed. And rather than having your users look at a loading indicator, just let them put their wrist down, put their phone down, and then tell them if something happened to go wrong, and let them fix it. See, these are just little seconds, but they can have a huge impact. And one of the design goals that I had when building Loop was to minimize the total number of minutes of usage per day. This is a selection. I've been recording this from the beginning. Some of these days are really great. I open this app less than 5 minutes total during the day. Some days I'm developing and it's much higher, but this goal is admittedly a little antithetical to those of us who've worked in the technology industry in publishing or marketing or advertising, where it's all about getting more eyeballs into our apps. But honestly, that's not what users want, especially when they're dealing with their health. So think about how you can reduce engagement with the user's disease, even if that means less time in your app. Your users will thank you for it. Finally, let's talk about accessibility. Today's smartphones are incredibly transformative to users with varying needs and abilities. And one of the great technologies for this is called VoiceOver on iOS. It provides a way for users who are blind or have low vision to interact with their smartphone. And I wish I could say that vision impairment was not related to diabetes, but unfortunately it's one of the largest cases, or largest contributors to it. So you'd think that diabetes apps would be leading the way here, but if the audio is on,
dim, button,
yeah, you have no idea what's going on. unless you can see the screen in some of these diabetes apps I tested. So it was a goal for me to actually provide an experience for low vision users in Loop. And so you may want to close your eyes, or you can watch if you like, but this is what it's like to use Loop with low vision after you open it.
Loop ran 4 minutes ago. Closed loop. Glucose, 112 at 10 p.m. Flat, needs attention. Net basal rate, minus 0.9 units per hour at 9:41 p.m. Reservoir volume, 110 units remaining at 9:59 p.m. Battery level, 50%. Glucose, eventually 73 mg/dl.
I'm very proud to tell you that it's not just reading data, but that Loop and RileaLink actually provide the most accessible bolus experience that I've ever seen.
Bolus, button. Bolus, bolus amount, text field, is editing, 0.0. Character mode, insertion point at start. Recommended bolus, 2.95 units. 2. Period. Period. 9. 5. Deliver, button. Deliver. Alert, touch ID for Loop. Authenticate to bolus 2.95 units.
So yeah, this is much better than listening for beeps. This is a full experience. And I believe the diabetes app should be setting the example for the rest of the healthcare app industry to make things accessible to more users. It's really never been easier to do this correctly and safely, and now's the time to do it. All right. I want to go over those 5 things one more time we talked about. 5 challenges I have for you. Be interoperable. See how your app fits into the ecosystem of everything the user is using. Second, be connected. Design for the real-time caregiver from the start. And if you don't want to build a backend, talk to the Nightscout folks here today. Third, be transparent. Allow your users to trust your system by validating its complexity. Fourth, be discreet. Optimize your UX flows for spending less time with your app and less time with the user's disease. And fourth, be accessible. Bring your app to more people. Thank you very much for having me today. We're going to have a great DDATA, and go build amazing apps.
We would like to thank Nate Racklyeft, Amy Tendress, and Howard Look, in addition to all the others that participated in this live broadcast. The 2016 DDATA Exchange and Diabetes Mind Innovation Project were made possible by Dexcom and other industry leaders in our T1 community.
This has been a Nightscout Foundation production. Come change the world with us. Learn more at nightscoutfoundation.org. In association with the Coexist movement, let your voice be heard while you still have a choice. And in association with CGM in the Cloud, open source, open data, open hearts. Caring for you and your loved ones around the world and around the clock. We now return you to your regularly scheduled life, already in progress.